So we are now in week 5, and this week I'll discuss science chapter 3.1, that is recognize the basic atomic structure, and then the physical properties and changes the matter. You can see this number 3.1, that is then TEAS ATI study manual, that is the textbook. If you go to the textbook, and you'll find in this chapter. So the learning objectives in a basic atomic structure, you will able to describe the structure of an atom after complete this chapter. You will identify the number of electrons, protons, neutrons in an atom, and use the periodic table to explain and predict the properties of elements. Okay, so the electrons, before we start in details, what is electron? Electrons are the subatomic particles carry negative charges. Electrons carry negative charge. And what is protons? Protons carry positive charge. Good. And the neutron, yes, have no electrical charges. No electrical charge.
Yeah, meaning that it's neutral, right?
Yes, the
Professor?
neutral, correct. This is no electrical charge. Okay, great. Let's start. So the atoms, atomic number and atomic mass. So what is atoms? An atom is the smallest and fundamental constituent of matter that retains the properties of an element. So it is the smallest subatomic particles and that retains the properties of an element. For example, iron. If I just write the iron atoms, many iron atoms to form the iron elements. That means the elements contains many, that means it's the many same type of atoms. So if you can see here, just I gave an example. An element is a substance that consists of atoms. So what is element? Element is a substance that consists of atoms. You can see the many atoms of iron to form the iron element. Now, this is again very important to understand the element. As I discussed here, what is element? So element is a substance that consists of atoms. Is a substance difficult to write. It consists of atoms. And the element cannot be split into simpler substance using normal chemical method. We cannot split the element. So, for example, the iron atoms to make up iron element. So element consists of atoms. And the atom is the smallest and fundamental constituent of an element. So the smallest particles of an element is called atoms. And the atoms consist of 3 subatomic particles. Proton, the proton carry positive charge, or P plus is the positive charge, and the neutron have no electrical charge, and electrons carry negative charge. So that is the negative charge electron, and proton carry positive and neutron is a no charges, no electrical charge, neutral. Now you can see the atomic structure on the right corner of the slide. So each atom consists of the atomic nucleus. Let me use the different color. Atomic nucleus that is in the center. The central part of an atom is atomic nucleus, and the atomic nucleus contains proton and the neutron. You can see these two important subatomic particles to form the atomic nucleus. Proton and neutron from atomic nucleus. Okay. And the next, the electron shell. You can see the electron shell. The electron shell, which is the outer circle, you can see, which form an orbit that encircle the nucleus. So this is called electron shell, and electron shell carry electrons. Okay. So what is electron shell? Electron shell, this carry the electron, and that looks like an orbit around the nucleus. So that is electron shell, and atomic nucleus proof contains the proton and neutron. Now you can see here the proton and neutron to form atomic nucleus and electron around the shell, which is called electron shell. Any questions about the atomic structure, please? So the atom is two-part, nucleus and shell. So the nucleus contains proton and neutron, and electron shell carry electron. Is it clear?
Yes.
Okay. Now, some important term you have to remember: the atomic number, atomic mass, or mass number. Let's come atomic number. What is atomic number? The number of protons is referred to atomic number. So the number of protons that an atom has in its nucleus is called atomic number. Now you can see here, look, can you answer the atomic number of carbon? What is the atomic number of carbon? What is the atomic number of carbon?
It's 6.
6. How do you know it's 6?
It's the positive.
Yes, there's a 6 proton. You can see the purple color, appreciate it. 1, 2, 3, 4, 5, 6. So there are 6 protons. So atomic number of carbon is 6. So for carbon, it is 6. So what is atomic number? The number of protons. Now, atomic mass. So atomic number of protons, and atomic mass is the number of protons plus number of neutrons. Okay, let's see here. Can you calculate the atomic mass from atomic mass of carbon? Can you calculate the atomic mass of carbon?
So that's 12.
12. Can you
11? Oh, it's
12?
12?
Can you explain?
12, yeah, 12.
Yes, can you explain how did you get 12?
Atomic mass, you said, was the protons plus the
Plus
neutrons.
neutron. 6 proton plus 6 neutron is atomic mass. So this is two very important concepts: atomic number, the number of protons, and atomic mass, number of protons plus number of neutrons. So these two are very important concepts. Okay, now the valency electrons. So before explain the valency electron, let's see this. Okay, let me. Okay, look the carbon atoms. Can you count the number of electrons? How many electrons here? Can you count the number of electrons?
6.
1, 2, 3, 4, 5, 6, right? And number of proton? That is 6. This we consider the carbon. So all the atoms are electrically neutral. You can see all the atoms are electrically neutral, means equal number of proton and equal number of electrons. This is another important characteristics of atoms. So all atoms electrically neutral. If you can see the carbon atoms, the carbon atom is electrically neutral because carries 6 protons and 6 electrons. Electrons negative charge and proton positive charge. Now, electron is organized around the orbit we called electron shell. You can see the first orbit. This is the first electron shell, can hold maximum 2 electrons. This is the rule. Can you see the 2 electrons in the first shell? Look. So the electron organized around the nucleus. So the first shell carry 2 electrons, maximum 2, not more than 2.
Okay, so the
And
first
this,
shell is
yes, 2.
always inner shell?
Yes, inner shell. Inner shell can take maximum 2. And the second shell can take, if you can see the carbon, 6 electrons. So there's a 4 remaining electrons into the second shell. But the maximum capacity in the second shell is 8. So the inner shell can hold 2 electrons maximum, and the second shell can hold 8 electrons maximum. So there is a simple a formula I just give. You can easily calculate the number of electron distribution, 2n square. Now n representing number of shell. So inner shell 2 into 1 square. So how many electrons? 2. Now the second shell, 2 into 2 square. That is 8. So the second shell can hold 8 electrons. Can you calculate the number of electrons into the third shell? Number of electrons will be in the third shell. How many electrons? These are the maximum capacity. The second electron.
That's 12.
No, you can see 3 square. That means 9. 2 into
Oh,
9,
927. Oh.
18. I mentioned n means number of shell. The first shell can hold 2 electrons, second shell can 8, third shell can hold maximum 18 electrons. So this is the number of electrons around the electron shell. Now, what is the valency electron? That is very important. The valency electron. The valency electrons are in the outermost shell of an atom and participate in chemical reaction or bonding is called valency electrons. Now, can you calculate the valence electron here? Can you calculate the valence electron?
4.
Is 4, correct. So valence electron is 4, good, appreciated. You know why there is 4? Because this is the outer shell have 4 electron. 1, 2, 3, 4. So the valence electron in carbon is 4. So the valence electron are the outermost shell of an atom and participate in chemical reaction. So we learned the atomic structure, the two basic parts, the nucleus and atomic shell. The nucleus consists of proton and the neutron. Proton carry positive charge and neutron carry neutral charges or no electrical charge. And atomic shell or atomic cloud. Atomic shells or atomic clouds uh, that surrounds the atomic nucleus and contain the electron. You can see the electron, and the inner shell can hold 2 electrons, and the second shell can hold maximum 8 electrons. So this is the distribution of electrons. We learned the atomic number, that is the number of protons is atomic number, and we learned the atomic mass, number of protons plus number of neutrons. And then you learn the valency electron, the outermost shell of an atom that participates in chemical reaction is the valency electron. So in this example, the carbon atoms, the outermost shell has 4 electrons. So the valency electron in carbon is 4 because there is 4 electrons. Now the isotopes, definition of isotopes is an atoms of same element have different number of neutrons, but same number of protons and electrons. That is isotope. So the number of electron and proton same, but neutron number is different. So that is called isotope. So for example, the isotope of carbon is 12. Okay, the carbon 12. This is a carbon isotope, carbon 13. So we can easily calculate the number of protons remain fixed is the 6. And what is the number of neutron here? 6. So that makes C12 carbon isotope, C12. And the C13 number of proton is constant, but number of neutron can be changed is the 7. So that is C13 isotope. So what is isotope? Atoms of same element have different number of neutrons. You can see the carbon may carry 6 or 7 neutrons, but same number of protons is called the isotopes. So what is isotope? Isotope is the atoms of same element which carry the different number of neutrons, but same number of protons. I can highlight same numbers of protons, but different numbers of neutrons. For two example, isotope of carbon 12 carries 6 protons and 6 neutron, and C13 is 6 proton and 7 neutron. You can see the same number of protons with different numbers of neutron. That is isotope. Okay. Let's check another example. Let me draw. The hydrogen. Hydrogen has 1 proton. You can see the nucleus carry 1 positive charge. Therefore, hydrogen has 1 electron. You can see the electron. So the hydrogen has 1 proton. And what will be the atomic number? What will be the atomic number of hydrogen? What will be the atomic number of hydrogen?
2.
Atomic number. Atomic number means number of proton. So
Yeah,
what will be 1? Now you can see here there is no neutron. So what will be the atomic mass?
1.
Yes, 1. So that is 1.
Mm,
Now hydrogen has another isotope we call deuterium. Deuterium. Let's write the deuterium. Deuterium carry a single proton and single neutron with single electron. So what will be the atomic number of deuterium? Same, because this is the isotope of hydrogen. Atomic number is same, but what will be the mass number or atomic mass in deuterium?
Is it 2?
2, 1 plus 1, 2. Because of variation of the neutron. So the isotope have the definition of isotopes that we learn. Same element that have different numbers of neutrons, but same number of protons.
So
Is called
titanium is an isotope
yes, isotope of hydrogen.
of hydrogen. Okay.
Okay. Let's give another example. Let me explain. Okay. Oxygen. Oxygen. This number representing atomic number. Okay. So what is atomic number? What is atomic number?
Number of protons.
Number of protons, correct. So the number of proton is fixed, appreciated. So its oxygen has 8 number of protons. Now, the 16 is the mass number. So this is 16. Let me draw the 3 oxygen elements. So the upper number representing the mass number and the lower number is your atomic number. Atomic number. So atomic number means number of proton, right? So in oxygen, the number of proton is 8. You can see the same atomic number. And the top number representing atomic mass. So can you calculate the number of neutron here? Calculate the number of neutron. This is the mass number 8, because the mass number means number of proton plus number of neutron. So that is 16. Now, in this oxygen elements, the neutron is 8. Now, can you calculate the neutron from here? This is the neutron. 8. And
9.
number 2, 17 is the mass number, proton number is 8. So what will be the number of neutron?
9.
9. That is a 9. 17 minus 8, 9. Number third one, can you calculate the atomic neutron? 18 minus
That's 8.
10.
10. 10. Now you can see that these 3 are
18.
isotopes of oxygen. One is O816, O817, O818. This is an isotope of oxygen. So O816 carry 8 neutron, O817 is a 9 neutron, and O818 is a 10 neutron. This the upper number representing the mass number. So what is atomic mass? Number of proton plus number of neutron. Now we can define the isotopes. The atoms of same element have different neutron. You can see the neutron number is different, but the same number of protons, the same number of protons, but different number of neutrons. So that is isotope. So this is the periodic table. Now let's start the periodic tables, and the table element expressed in column and rows. So you can see here the now you can see the columns. Can you count the number of columns? Let me zoom in. It's not clear. Can you count the number of columns? 1, 2, 3, 4, 5, 6, 2, 18. So the number of columns is 18. That is, elements are grouped 18 groups into vertical columns because they have identical chemical properties. So that is, columns are called groups. So there are 18 groups. So this is columns. And this is the rows. Can you count the number of rows? Let me zoom in. 1, 2, 3, 4, 5, 6, 7. So this is the 7 rows, also called the periods. So the group into 18 groups, that means 18 columns and the 7 periods. This arranged horizontally in ascending order of their atomic number. Ascending order of atomic numbers known as periods. So this is the column and the rows. The column, also called the group, and the rows called periods. And number of columns is 18, and the number of rows is the 7. Now, the atoms are arranged from left to right. You can see the from left side to the right side by increasing atomic number or number of protons. If I can zoom in, let me. Can you see the periodic table here? This number representing number of. What is this number representing? Number of.
Well, that's the number
Column.
of the
Column.
Yeah.
So 1 to 18 is the columns, and 1 to 7 is the rows. So what is the importance of columns? The columns are called the groups. So there are 18 groups, and the rows are called the periods. So these are the periods. So there are 7 periods. Now, if you can see the each square is representing the elements. So you can find some number. The 26, for example, the iron, Fe is the iron. And you can see the 26. This 26 is the atomic number. So atomic number of iron is 26. So what is atomic number? What is atomic number?
The number of protons?
Number of proton. You can see here the carbon, the number 6. That means number of proton is 6. And can you see the number at the bottom? There's another number at the bottom.
Oh, the mass.
With
the left.
decimal. So that is the mass number. So what is mass number? Number of proton plus
Neutrons.
Neutrons.
So this is the mass number, and the top number is the proton number of protons. Okay. So this is the symbol and the molecular formula of the elements. For example, Fe with a symbol and the name of the element is the iron. Ti is the titanium and the Ti is the symbol. So you can see the symbol. For example, H is in hydrogen and you can see the name is in hydrogen. So we can, you have to read the periodic tables. You have to read the number, that is the atomic number, and you will with decimal, that is the mass number. And then you have to know the symbol and the name. Okay, now the importance of there is a pattern to look for. There is an obvious pattern to look for. Atomic number increases as you move right along a row. Let's pick up a row, for example. I just make a row. You can see. I just highlight one row. Can you see the atomic number? 37 is the atomic number, right?
Mm-hmm.
Atomic number increases as you move right along a row. 7, 37, 38, 39, 40, 41, 42, 43, 44, 45. Can you see the elements with increasing atomic number? So in each row, if you can see here, look, sodium, magnesium, 11, 12. The row number 4, 19, 20, 21, 22, 23. So atomic number increases as you move right along a row. Is it clear? You can see here.
Yes.
That means from left to right, this is the left and this is the right. So from left to by increasing atomic number. Now you can see the row. Let's see the row. In the row, atomic number increases as you move down. You can see increase atomic number 4, 12, 20, 38. So atomic number increases as you move down a column. Okay. So each element is represented by a chemical symbol. We have seen the chemical symbol. And atoms from left to by increasing atomic number. And we learned atomic mass on the periodic table are shown in decimal. You can see here the decimal, that is mass number. And the arrangement of known element based on atomic number and chemical and physical properties. And the chemical and physical properties and divided into 3 basic categories. Now let's see the basic pattern or category of a periodic table. The left side of the table representing metals. You can see this all are metals. If I make a line, I think the next slide will see better. We can make a line here. So these are the metals. These all are metals. And the right side is non-metal. So these are the non-metal. If I write here in the periodic table, these are the metals. Okay, let me clean. These are the metals. Left side of the table. And this is non-metal. These are the right side of the table. Then there is a zigzag line. You can see here the zigzag line is not clear. This, if I can draw the zigzag line. For example, we can draw here. Can you see the zigzag line? Let me draw the zigzag line. This is the zigzag line. So these elements are called metalloid. Metalloid means these are metal and non-metal, both properties having metal and non-metal. So this is called the metalloids, carry both metal and non-metal. So the metals on the left side, these are the metals, and on the right side is the non-metal, and in between there's an area which called the zigzag line is a metalloid. Metalloid means both metals and non-metals. Okay, so the metals left side of the table, non-metals on the right side of the table. This is the non-metal, and the metalloids touching the zigzag line. So this area is the metalloid. So what is metalloids? What is metalloids? Having both,
Can be both.
yes, metal
Metal.
and non-metal properties.
Was that zigzag?
Professor, hold on. So
Is
how
it
do you know where to start the line, where the left side start and where the right side start?
okay?
Do
I'll
you put
just
it in the center?
okay. No. You can start from here. Let me show you the zigzag line. Number 5. We can let me clean it. Actually, this is not clear. You can see the green lines. Can you see the green green box? Green box.
Mhm.
We can move the line this area. So then 14. So this is the zigzag line. Can you see the zigzag line?
So it ends at OG.
Yep.
Mm.
So these are the mostly these are the non-metalloid. These are the metalloid. These are the metalloid, and this metalloid are both metal and non-metal. So these are the metals, and these are the non-metals, and these are metalloid. The metalloid means having both metals and non-metals. So even you can see the green circle. Can you see this actually the green lines? They didn't draw the zigzag line clearly. These all are metalloids.
Oh.
So these all are metalloids. So what is metalloids? Have both metal and non-metal properties. Okay, I think you can see here. Just can you see the green color structure here? This
Yeah.
green.
Oh, that's
These are the
Yes.
metalloids. These all are metalloids, and these are metal, and these are non-metal. Now is it clear?
yes.
Okay, let me. So this green color is metalloid, and these are metal and non-metal. So the elements are grouped 18 into vertical columns because they have identical chemical properties, and arranged horizontally in ascending order of their atomic number, which is called periods. The period also called row, and the group also called columns. Number of columns 18, and number of groups, number of period 7.
7.
7.
Professor, what
Yes.
happened to those two
Oh,
detached
these are
rows?
lengthen side series and actin sites. It is not considered. This are not considered because this identify later. Okay, these elements identify letters, not at the same time. These are the main elements. These are the main elements, but these elements identify letters from modifications or
Okay.
some other changes. But these are the main primary group. 7 group is the primary. Now let's see the color. The most of them has some important properties. You can see the gas, the noble gas. Yeah, if you can find the color, these are the gases. So I mentioned earlier the columns with a specific property, and if you can see it, then number 18, these all are gas. Can you see the 18? These all are gases.
18.
In number group, that is the
Oh,
columns 18. You
okay.
can see the color. These all are gas, noble gases. You can see here color. So that is even you can see here a group number, column number 17. Number 17. So this color, this all are halogen. This is then halogen gas. This also halogen gases. If we can see the group number 2, I mean, sorry, columns, column number 2. These are alkaline in the earth, same properties. So these elements have same properties. So what is the importance of group and columns? Is you learn there are 18. How many columns? How many columns?
18.
18 columns. So and there is 7 rows. But if you can see the columns with a specific properties, if you can see the columns having a specific properties with chemical properties, and in the group you can see the increase the atomic number. If you can see the group that's as plotted to increase the atomic number, like potassium atomic number 19, then 20, 21, 22. So the group are organized to increase atomic number, and the column is according to their physical properties. So the group have identical chemical properties, and the periods or rows arranged horizontally in ascending order according to the atomic number. So you can see the atomic number increases if you go from left to right. Now let's see some do some exercise based on these informations. Can you see the questions?
Can you enlarge that a little bit,
Yes.
please?
Let me enlarge. Where is the zoom button?
Mm,
Where is the zoom? Oh, here. Is it clear now?
okay.
Okay.
Yes.
Is it okay?
Yes.
Okay. Now, can you please try to answer which subatomic particle carry negative charge?
C.
See?
Electron.
Electron carry negative charge. Good. And what about proton? Proton carries
Positive.
positive. Neutron carry
Neutral.
no
No charge.
no charges, and electron carry neutral. I mean negative charge. Good. Okay. Let me zoom out a little. Okay. I'll zoom in later. Which of the following neutral atoms would have 10 protons, 11 neutrons, and 10 electrons? I think to explain these questions, you have to know the periodic table. You can see the number of proton is 10. If I zoom in the periodic table, let me show you. Can you find the number of the proton, the which elements has 10 protons. Can you find the 10 protons on the periodic table?
Okay, so
Neon.
Yes, correct. So the
Neon.
neon. Yep, let me zoom in the neon. You can see here the neon. 3, 4, 5, 6, 7, 8, 9, 10. So the neon. Good. So the appreciated, very good answers. So this is the neon. So the neon have 10 protons, 11 neutrons, and 10 electrons. Now you can see number of protons and electrons is always same because all atoms electrically neutral. Which of the following subatomic particles are found inside of atom's nucleus?
B.
Yes, the neutron and protons in the nucleus, atomic nucleus. If you can see here, the nucleus, atomic nucleus, carry the proton and the neutron. Good. An electrically neutral atom with atomic number 8 and mass number 17. Which one is correct? Answer. Atomic number 8 and mass number 17. You can find that.
Is it B?
Why? Because if you can,
Because
18
the
minus
mass
17
number
minus.
take away the atomic number, which is
So
9.
but the 9 is the electrons. It's not atomic. The 9 is the electron. Electron is the negative charge.
8 and a mass number of 17.
Mass number 17, atomic number 8. So which of the following is the correct answer?
Oh, it's D.
No. Okay. What is atomic number? What is atomic number?
8.
So
Number of protons.
number of protons. So you can see here 8 protons because the atomic number 8 means it's in having 8 protons. So electrically neutral atoms with an atomic number 8 means having 8 protons. Is it clear, these questions? So why B is incorrect? Because all electrons are electrically neutral. If having 8 protons should be 8 electrons, so this is incorrect. Now why C is incorrect? Because what is the mass number? Mass number is
17.
17. Now can you calculate the number of neutrons from here? You know the proton is 8, mass number is 17. What is the neutron number? What is mass number?
Protons and
Neutron. So you know the number of proton is 8. You know the mass number. Can you calculate the number of neutron?
9.
9. So but here no, option C is 8. So this is incorrect. Now D is incorrect. 17 protons because the 17 representing mass number. So just try to remember atomic number equals to number of protons and the mass number equal to number of proton plus number of neutrons.
Oh, I get it now. I get this. It's a tricky question.
Yes, this is the tricky questions.
They're just asking you what are the protons, really?
Yep, correct. An unknown element is found to contain 45 protons and atomic mass 64. What is the atomic number? Having
Atomic
40.
number is protons, so
45.
Yes, correct.
if
Because
I
the
45. It's the
correct.
same thing.
Atomic number, yes. So
Mhm.
atomic number will be the 45. So
Yeah.
now what is atomic number? Atomic number means the number of protons.
Protons.
So number of protons is the atomic number and atomic mass, number of proton plus number of neutron. An atom of iron has atomic number 26. Which of the following is true?
A.
Please read the questions. The questions is the atomic number. Atomic number is 26, means
Oh, proton. They
is
do.
number of protons.
Yeah,
So
so it's B.
B. So iron has 26 proton. So remember, atomic number means number of protons,
Mm,
atomic mass, proton plus neutron. Okay,
mhm.
just I give a simple.
Mm.
Okay, let me just write atomic number means number of
Protons. Atomic mass is protons and neutrons. I have to get that in my head.
atomic mass, number of protons plus number of neutrons. So please don't forget, this is very common questions in these exams.
Mm.
So atomic number is the number of protons and atomic mass in number of protons plus number of neutrons. Just try to check your understanding that the carbon, if I can write the carbon, the protons number of protons is 6 and neutron is 6. Now, can you calculate the atomic number of carbon? What is the atomic number of carbon?
It's 6.
Yes, 6. Proton, it is 6. And can you calculate the atomic mass of carbon?
It's 12.
12.
12.
Because 6 plus 6, 12 is an atomic mass, and number of proton, that is 6, is an atomic
Mm.
number. Okay. The atomic number represents the number of, again, the same questions you can see, because this is very important. The atomic number represents the number of,
B.
B.
yes, protons in an
Protons in
atom.
an atom. Hmm.
Which of the following is atomic mass of an atom containing 42 protons, 42 electrons, and, okay, let me zoom out, and 37 neutron. You
Oh,
can,
okay. It's D. 42, 42.
you can see the electron is not involved in atomic
Mm.
mass.
Very
Atomic mass means number of proton plus number of
neutron. So it's
neutron.
84. C.
So 7 to 9 and 37. So
B.
that is B.
Oh, B.
So,
What?
so the mass means number of protons plus number of neutrons.
Correct.
Please, I explain here the atomic mass, number of protons plus number of neutrons. What
So
contributes to calculate the mass number?
protons and neutrons.
Number of
Yes,
protons plus the
sum
number of
of
neutrons.
protons and neutrons. Now, what varies from one isotope of an element to another isotope of the same element?
What varies from one
Isotopes.
isotope?
Yes,
Is it the mass number?
yes, correct.
Yeah.
Mm-hmm.
The
That's
mass
that.
number. Because I gave some example here, for example, the
Where
oxygen. I
protons is
gave oxygen, for example, the O8. So this 8 representing the number of proton. If I can subscript. So you can see this. These are the 3 isotope. isotope of oxygen. And now I'm writing the number of 16. This is the mass number. You can see this is the one isotope. This is the mass number 17. And this is the mass number of this oxygen. Now, the upper number representing the mass number and that's the proton number. So isotope, same number of proton, but different mass number. Can you see the different mass number? So this is one isotope, 8, 16, 17, and 18. So this number representing the mass number. The top number. And this is the number of protons. So this is an isotope of oxygen. There are the three isotopes, 16, 17, and 18. That's 18, 17, 16 representing mass number, and this is the number of protons. So the mass number. The two isotopes of carbon are found, one with an atomic mass is 12 and other 14. Which of the following best describes? There are two isotopes, one is a 12 and 14.
Oh boy, I think it's A. The number of protons and electrons is different.
Remember, electron does not contribute in isotopes. So isotope depends on proton and neutron.
Okay.
Now, the atomic mass 12. Can you remember the number of protons? What is the number of protons in carbon?
It's 8.
No, 6. Carbon has 6 protons.
Sorry, 6.
So carbon has 6 proton and atomic mass is 12. Can you calculate the number of neutron from here?
Oh,
6.
6. So this is 6 neutron and that these isotopes. Okay, let me write it here. Okay, the questions, if I can first, then carbon. See, proton number is 6 and the mass number 12 and another one is 6 and the mass number was 14.
14.
Okay, now you calculate. Can you calculate there's a two isotope, one is 12 and 14, carbon 12 and carbon 14. Now can you calculate the number of proton here? The first isotopes, calculate the number of proton.
It's
Number of
6.
neutron. What will be the number of neutron? Because this is the
6.
mass number. So how can you calculate the number of neutron?
Oh, so that's 6.
6. Okay, the first C612 is it? Oh, sorry, this is the number of neutron.
And then
Equal to 6.
is
So
8.
yes, so this is 6 and number of neutron here will be 8, right?
Hmm.
Will be 8 because the number of neutrons is different, but number of proton is same, if you can recall the definition. So now you can answer. The two isotopes of carbon are found, one with an atomic mass 12 and 14. Which of the following best describes? Now the carbon 14 has more neutron than carbon 12. You can see here the carbon 14 has 8 neutron and carbon 12 has 6. So the carbon 14 has more neutron than carbon 12. So the carbon 14 has more neutrons than carbon 12. Okay. What characteristics of an element determines its specific isotopes? Which
This
determine?
be B. It's got to be B.
Yes, number of neutrons.
Okay.
because the number of proton is same, but number of neutron is different. Uh, a neutral atom of calcium has 2 electrons on outer shell. Which of the following will occur when calcium ions forms an ion? Okay, I think I didn't discuss these questions. I'll discuss on Wednesday, but the correct answer, calcium will lose 2 electrons to have full valency shell. I'll explain this concept on the Wednesday. So I think I'll stop here because the remaining concept will be discussed on Wednesday. But anyway, I think you can answer these questions. Number 14, determine the number of protons in an isotope of nitrogen with atomic number 7 and mass number 14.
7.
Yes, 7.
Mm-hmm.
So the 7 is an atomic number. Atomic number is the number of proton, remember. The number 15 I'll discuss on Wednesday, not today. And these are the atom ionic bonds that this objective not yet discussed today. I'll discuss on Wednesday. So today we learn the atomic structure. We learn the subatomic particles and atomic number and the mass number. So before I conclude, just quick review. So what are the structure of an atom? The atoms, each atom has 2 parts. The atomic nucleus carry proton and neutron, and electron shell carries electron. So the protons carry positive charge, electron carries negative charges, and neutron is no charge. So the number of protons determine the atomic number, that is the number of protons, and the number of proton plus neutron that determine the atomic mass or mass number. And the electron, which helps in ionic bond formation or involves in chemical bonds. And we learned the isotopes. Isotope means same number of protons but different numbers of neutrons. That is an isotopes. Same number of protons and different number of neutrons. So we learned the periodic tables, and there are 18 columns and the 12 rows. So, and each box representing the element with the atomic number, the mass number, and the symbol and the name of the element. Okay, so that's the end of the today's session. Any questions, please?
No,
I'll
sir.
I'll continue this